Good morning, folks. We come for yet another video of the application of derivatives. We had started with the application of derivatives. The first application, rate measurer, is over. Now we are going for the next application. It is called as increasing and decreasing functions. Increasing and decreasing functions as such is important. It's quite important, and it's very easy to follow this because there is a stereotype way of working. You just follow that uh, working style. For every problem you have to follow that same step. So that's how so working becomes easy, and it's important from the exam point of view, also the board exam point of view. So that's it. As we take up the problems, I'll let you know how we can do it. Actually, there are two methods of doing increasing and decreasing functions. The first method, I'll let you know how it is, and then we'll go the second method. So right away we will start with the exercise 6.2, question number 1. Question number 1 says that show that the function f of x equal to 3x plus 17 is strictly increasing on R. So they are telling us that the function is 3x plus 17. You have to tell that it is increasing on R. Now we could do it, as I told you, there are two methods of doing it. Here we are doing it by method 1. Most of the problems will be doing by method 2 because that's more concise. That's more precise way of doing and works okay with most of the problems. So but we'll just do by method 1 so that you can get to know how to do that problems by this method. Now they've told us that you have to show that it is increasing on this. So if you have to show that a particular function is increasing, the step that you need to follow is, first you start with x1 less than x2. Devise your steps and somehow show that f of x1 is also less than f of x2. Then it will be an increasing function. On the contrary, if you start with x1 less than x2 and you are able to show that f of x1 is greater than f of x2, the inequality is reversing. Then in this case it will be an increasing function, and if the inequality is reversing, then it will be a decreasing function. So this is the method 1, and this problem we'll just do by method 1 so that we get an idea of how to use this method. So let's right away start with this. So for all this, let's consider x1 less than x2, only then we are able to work out like this. So let x1 less than x2, since you have to reach this function, you have to reach 3x1 or 3x2 plus 17, we'll gradually devise our steps so that we reach here. So the first thing that you're going to do is, we are going to multiply 3 on both sides. So let's multiply 3 on both sides. 3x1 is less than 3x2. So also, since we require 3x plus 17, so let's add 17 now on both sides. So when you add 17 on both sides, you're getting, so that means that you're getting 3x1 plus 17 less than 3x2 plus 17. But this we all know it is f of x1. And this we all know it's f of x2. So therefore, what has happened? We started with x1 less than x2 and we have reached f of x1 less than f of x2. That's why the function f or f of x is an increasing function. As I told you, so method 1 of doing it. So also we'll go to the second problem where we'll do it by the method 2, where we have a different step. For method 2, what we do is we'll take the function and we'll take the derivative, and we will check how the derivative behaves. On the basis of that, we'll be probably able to tell the increasing and decreasing function. So that's going to be for the next problem. Our next problem is f of x equal to e raised to 2x. So let's go for that. As I told you, in the second method, what we do is, after you have got the function, you are going to take its derivative. Let's take the derivative. F dash x. Derivative of e raised to ax, we all know, is a e raised to ax. That is 2 e raised to 2x. Okay. Now, if the function is increasing, they have told us to check whether the function is increasing on R. So from minus infinity to infinity rather. it is increasing. That's what they're telling. That's what they're asking us to show. See, if the function is increasing, then on a particular interval, the f dash x should be greater than 0. If it's decreasing, then in that interval, f dash x should be less than 0. This is the idea. So if it has to be, if this function has to be increasing on r, that means on the entire real number line, f dash x has to be positive. Then only this will happen. Okay, so our idea is to show that this particular function is positive on the whole real number line. And that is true. Why? Because the exponent function we have learned earlier when we learned the expansion. Basically how it will expand like this 2 times. E raised to 2x means it's 2x plus 2x raised to 0 by 0. Oh yeah, 1 factorial by 1 factorial plus 1. This is 1. 1 plus then 2x raised to 2 by 2 factorial and so on. That's how the terms continue. It's very clear to us that as the terms proceed, this it has to be positive. Whatever way that it goes, it will be always positive. So that's how this expansion f dash x is positive for all x, for x belonging to real numbers, and therefore fx is increasing on r. Why? Because f dash x is positive for all values of r. That happens for every exponential series is always positive for whatever be the value of, whatever be the real value of x. So that's about it. And then we are moving to the next question, the third one, which says that show that the function is okay. They tell us that show that the function f of x is sine x equal to sine x. Now we will learn the stereotype method of doing this problem. Whenever you're given increasing decreasing to show, first the steps that you have to follow is first take fx, then take f dash x. That's going to be your step always. Take f dash x. So if it's f dash x, the derivative sine x we all know is cos x. Now, if they have given you some idea about the intervals, fine. Otherwise, we have to find out on what intervals we have to check. For that, we have to find something called as critical points. How do we find the critical points? By making f dash x equal to 0. Luckily for us in this problem, they have told us everything about the intervals. So we have to check only on the interval. So that step of finding the interval, no need to do. If it's not given, then you have to also devise up that step by which you get the required interval. So that is going to be like saved for us in this problem. They have told us in the sub question 1 that you have to check whether it is increasing decreasing on 0 to pi by 2. You have to check on pi by 2 to pi whether it is increasing decreasing, and then cumulatively on 0 to pi what's the nature. So in cases where they happen to tell us something about the intervals and things like that, we just go for a table directly. So what do we do in the table? We'll make a table with probably 3 columns. Let's have the table with 3 columns. This will help you a lot in the board exam also. Please go for the tabular form. I think it will be very useful for the examiner to correct and for you to do it also. You don't repeat the steps. Once you write the headings, everything is there. You don't have to keep on writing again and again, and I feel it's more convenient. So what we will do here, we will your first heading will be intervals. Second heading will be sign of f dash x. Next is the nature of the function. Okay. Now here, because they have told you that you have the open interval 0 to pi by 2, first let's take that interval. And to find out the sign of f dash x, you take any one point in this open interval and check what is the sign of f dash at that point. Like for example, 0 to pi by 2, we have got many. You have got 30 degree, you've got 45 degree, you've got 60 degree. So you can have pi by 3, pi by 4, pi by 6, whatever. Maybe we take pi by 4. Of course, that's your own choice. You can take anything in that open interval. So f dash at pi by 4 means it's cos at pi by 4. Cos at pi by 4 means it's 1 by root 2. Whatever value, we are not much bothered. We are only bothered whether it is positive or negative. It is positive. Yeah, we all know it's positive. If it is positive, then the function will be increasing. if f dash x is positive in a particular interval, then the function is always going to be increasing. So this is increasing. So this is how we are going to decide how it is. So we also move for the next interval. They have given us one more interval. So that also we will check and find out. The next interval that they give us is pi by 2 to pi. The next interval is pi by 2 to pi. Pi by 2 to pi means 90 to 180. Now between 90 to 180, the points that we generally check is 120, 135, such things. You can take anything. We could take 120. 120 is actually 2 pi by 3. So maybe you can take 120 f dash at 2 pi by 3. That means it is cos at 2 pi by 3. Directly we don't know the value. 2 pi by 3. Those who have kept it at their fingertips, very good. But if you don't know it, we have to find it. If you know it, it saves your time. You can write it directly. Actually, how we do it is writing 2 pi by 3 is as good as writing pi minus pi by 3. Isn't it? Just check pi minus pi by 3. We will always, whatever be the angle given, we will always try to get it in terms of pi and 2 pi, so that it's very easy to compute. So writing 2 pi by 3 is as good as writing pi minus pi by 3. When we equalize, etc., you get 2 pi by 3. Pi minus pi by 3 means it's a angle in the second quadrant, and second quadrant is a quadrant only for sine and cosec. So automatically all ratios are going to be, other than sine and cosec, are going to be negative. So the answer for this is minus cos pi by 3. That is actually minus cos 60, which is minus half or whatever, but that doesn't matter actually. Less than 0, it's very clear to us that it's some value. You can write the value, of course, but we are more bothered about the sign. It is going to be a negative thing. So how is the function here? Function is decreasing. Why? Because you've got the f dash value as less than 0. So function is decreasing. That's it. That's what they have asked us. Just find out whether it is increasing, decreasing. And then correctly they are saying that on 0 to pi, it is neither increasing nor decreasing. That's correct. Why? Because 0 to pi, it's made up of 0 to pi by 2. Actually, union pi by 2 is not included. Actually, pi by 2 somewhere should be included. Pi by 2 to pi. Yeah. So here in this it is increasing and here it is decreasing. So in a particular interval, some part it is increasing, some part it is decreasing. So on the entire interval, it is neither increasing nor decreasing. That's correct. That's what they have asked. So we can write, yeah, this is neither increasing nor decreasing. Why? We get it from part 1 and part 2. Already we have shown that on one part it is increasing, on the other part it is decreasing. So on the entire interval it is neither increasing nor decreasing. So that's it. That's about maybe this first part. With more problems, maybe we can take it up in the next video. Thank you.